Example 14.1b asks us to find the zeros and state the multiplicity for the equation provided. So it's already in factored form. So I'm going to go straight to saying let g of x be equal to 0, which is then going to say 0 equals 4 times x squared plus 4 times x plus 6 to the third. Now we saw on part A of example 14.1 that there's really no need to do anything with the factor of 4 because 4 is just a constant. But x squared plus 4 has a variable involved, so we'll definitely want to set that one equal to 0. So 0 equals x squared plus 4, or we could even look at x plus 6. Now I understand that x plus 6 is being cubed here, but all that means is that x plus 6 is there 3 times. So we'll take the exponent as a way for us to think about the multiplicity once we get to stating the final answer. So let me go ahead and say 0 could also equal x plus 6. So for the one that we just wrote, the answer comes out pretty quickly. X is going to equal -6. For 0 equaling x squared plus 4, I would subtract 4 from both sides, getting -4 is equal to x squared. And then I would take the square root of both sides. So when I take the square root of both sides, I have to make sure that I remember my plus or minus. I will have plus or minus the square root of -4 is all equal to x. And what we've been saying in the past is square root of a negative is non-real. And that's still true. It is non-real. But today we're going to actually explain the imaginary number concept, and we're going to not just say it's non-real, we are going to state what the imaginary number is that this represents. So let me come over here to the margin and let's talk a little bit about imaginary numbers. Imaginary numbers were developed for the very reason that we're having here. Mathematicians were seeing often this square root of a negative would appear in calculations, and so they wanted to define something to be able to replace the square root of a negative. So they decided that every negative number has a -1 built into it. So they defined just the square root of -1 to be equal to I. And then as a consequence of that, they said, let's also say that -1 is equal to I squared. So anytime we see I squared up here, we can just call that -1. Anytime we see the square root of -1, we can just call that I. So how does that end up helping us with the square root of -4? Let's take a look. So in our problem, we have the square root of -4. And as I said, mathematicians realize that every negative number has a -1 built into it. So -4 is really just the same as saying -1 times 4. And then by properties of radicals, we can write this as the square root of -1 times the square root of 4. The square root of 4 is already well known. It is 2. And we just defined the square root of -1 to be I. So our answer is going to be 2 times I, or 2I. So going back to our solving over here, we have plus or minus the square root of -4. So therefore we can say x equals plus or minus 2I. So there's two answers there. X is either equal to 2I or it's equal to -2I. So we're not going to any longer just say that something is non-real. We are going to actually specify how it is not real. So the 2I and -2I count as two different solutions, two different zeros, and they are both coming from the factor x squared plus 4. And x squared plus 4 is just to the first power. So they just have a multiplicity of 1 apiece. So x equals 2i comma negative 2i have multiplicity of just 1. Whereas x equals negative 6 has multiplicity of 3. And we'll box all that in, as that is what we were asked for, the zeros and their multiplicity.